Okay, so should we start? I think there are more people to come. Anyway, they will join in. Okay, okay, great. That's a great way to keep them. And Arun, also keep a backup of whatever you write in there. Okay, whatever you write there, you keep a backup because a student folder is shared with everybody, and everybody has a changing permission also. Okay, in case somebody deletes it, it will become a problem. Oh, great, great. So it's on Hadoop 1, right? It's on Hadoop 1 or oh, you mean HDFS, I think. Okay, I can see that. Yes, go ahead with your question. How to use Python script for mapper and reducer. Okay, okay. Probably I did not demonstrate you guys. So I would actually like to take a step back. So, so I had actually written down, yeah, okay. All right. So the way we have used, okay, you look at this code closely. All right. So the way we have used here, okay, and say you have a Python script, right? So, and you have got this folder here, all right, like this, and you want to create, you want to do this using a Python script, all right. So all you have to do is here is specify your Python script, okay, okay. So this mechanism of executing any program is called Hadoop streaming. It is little different. It is little different than using Java. In case of Java, I will explain today. But in case of streaming, you get a line by line input to your mapper, and your mapper reads it from the standard input line by line, and then gives out the key value pairs separated by a tab. The first key is, I mean, the the value just before the first tab is considered as the key, and rest of the things are considered as the value. And for the reducer, in case of a streaming job, the interesting part is that the reducer does not get it mm, in the does not get it grouped. Okay, reducer only get the values input as sorted list of key value pairs. Okay, okay. So here all you have to do is create your Python script like this. Okay, and make sure that this script exists on all the nodes. Okay, you have to make sure that this script exists at all the nodes. All right. So basically, the code in you'll have to copy that file all across to all the nodes. No, you cannot keep that script in the HDFS. You have to keep in the local file system only. Okay. Should I go? I mean, should I give you a little more deep perspective? Okay. Okay. So basically, there are two ways to program your map and reduce. One which we have discussed so far is the streaming way. In the streaming way, we could use any executable as mapper and reducer. Okay, we could use any executable as mapper and reducer. Okay, so basically whatever the input is provided as minus minus input folder here, so all the files will be concatenated, and line by line they will be fed to your mapper program. Okay, your mapper will convert each line into key value pairs. Key and value are separated by a tab. Okay, and that data is sorted by Hadoop and given to your reducer. Your reducer will take key uh, tab value from the standard input and then combine that. Okay. In case of reducer, generally reducer is only one. Okay, and so you can all imagine that all the input reducer is getting is sorted by the key. Okay, it's not grouped. When it comes to streaming job, the key value pair, key and values are not grouped. They are just straightforward a list of key value pairs which is ordered by key. And now it is the duty of your code to take that input and group it or do whatever it wants to do. Okay. So this is as simple as this. So similarly, if you have to code it in Python, you can write your code in Python, save it somewhere on the disk, and copy the same code to all the nodes in your in your cluster. Okay. Similar is the case with reducer. So whatever code you write in these files, copy that to the cluster, and that's all. Okay, and then you ask this Hadoop streaming jar to execute your mapper and reducer. Okay, so most of the things we have so far discussed is about streaming job. Okay, like all of this has been discussed with respect to streaming jobs only. Gunjan, feel free to ask this question in public so that other people can also understand. Okay. What if we have a big implementation? Is there an automation for code deployment? That's a very good question, Gunjan. And Arun was also asking the same thing. So let me explain to you this. Basically, these workflow engines such as Uzi and Azkaban earlier, they helped you synchronize the code all across the nodes by putting it into HDFS and then taking it back locally before execution. Okay, but the only problem there was only problem we faced was only problem we faced there was that the library which we are using in say Python code or libraries which we were using in Python or in case of if there is a version difference between the nodes in Python, then it will become a problem. Otherwise, everything works fine with the Uzi or Azkaban because they take your job, take your job, put it into HDFS, and on each data node, it is taken out from the HDFS and executed locally. Okay, so the code synchronization problem is very well solved by Uzi and other workflows. But right now, Uzi is the only one which is used. Azkaban has been stopped. Okay, but even with those Uzi and other systems, the problem always was with respect to the libraries. Okay, and to do that, we used to use a system called Puppet Master. Okay. Puppet Master's duty was to ensure and roll out all the packages to all the nodes. Okay. So to handle the two scenario which we discussed, first was how do we make sure that code is synchronized all across nodes. We used Uzi, and second problem was how do we solve the problems like uh, different versions of Python language, different libraries which are being used. We used to have something called uh, Puppet Master. Puppet Master helps you helps you deploy a package on all the nodes in your cluster, and it's a push mechanism. Basically, you can push the packages to all the clusters in a single go. Okay. Okay. So package installation etc has to be manually taken care. For the smaller installation, yes. For bigger installation, it is Puppet Master. Just note down the name. I'll just okay. It's called Puppet Master. Okay. The only value I bring in is that okay, not this. It's called okay. Okay. Yeah, this is what it is. Okay. Basically, we used to have this. Okay. And in case of Amazon, we had our own internal build system, which used to deploy any software to all the nodes in a single shot. While in case of InmoBee, we used Puppet. Okay, but we used to call it Puppet Master. It is actually Puppet. Okay, all right. When you are dealing with any cluster, when you are dealing with any cluster, these are common questions to be asked that how do you make sure this or that, J- and Puppet is one. Okay, right. And Puppet is actually used quite popularly. I have come to know that even at Flipkart they use it extensively, and the company called Mintra, which they acquired, they also were using Puppet. Okay, so Yes, Savita, if you are using even our cluster, this is actually required. So, if you i- if you have to execute a, a Python program, okay, you'll have to copy your uh, Python files to all the nodes into the exact same path and then execute it. Okay. So that way it will make sure that it executes all the code. So if you are, this is only true in case of, in case of streaming job. Streaming job is what we have discussed so far, where which can execute your mapper and reducer in the form of any executable. Okay. So as long as that executable you are trying to execute as part of mapper or reducer is available on all nodes, all data nodes as well as the master, it will work fine. Okay. So in case of our cluster also, it would be required in case you are using a streaming job. But in case you are using a Java thing, in case you are using a Java map reducer, then you don't need it. Okay. So let me take it to the our today's session. In today's session, we are going to extensively cover Java. So do not panic in case you don't understand. I will try to explain my best. Okay, all right. So half of the class is dedicated, I mean, extensively Java. Okay. Now we have got session number 3, session number 4. All right. Okay. So all of you, please make sure that you finish your assignment. Okay. Even if you are just writing steps, drop me an email. Okay. With your detailed comments, drop me an email, and I would like to review it. Okay. Because this is the very important exercise. Okay. Even if you are using any of the newer platforms, say Apache Spark. Okay. Or any other way, say MongoDB, Cassandra, or any other systems, map and reduce are the is the construct which is required everywhere all across. Okay. No, I mean, I have reviewed almost all the systems, and map reduce seems to exist everywhere, even in the latest ones like Spark. Okay. So make sure that you write down the steps in your own language or in any standard language. Okay. So this one I have not got replies from few people. Okay. So I, in case you are not clear, if you in case you are stuck with some point, just let me know. I can help you cl clarify a lot of things. Okay. Now moving on. Okay, so last time we left the whole discussion with this particular problem. And the problem was basically a pretty simple one. You are given a large corpus of text. Okay, large corpus of text as in there's a huge text available. And this text, you need to figure out based on this text, what are the most commonly used word after a particular word. Or what are the top 5 words used? What are the top 5 words used after a particular word? How do you do that? I got great solutions from some of you. Okay. And the easiest, the first one which I got is that, I mean, you take the text, okay, you take the text, break that into pairs, such as how are you, and here you ram, and Okay. And then Ram, happy birthday, and birthday to you. Okay. No, actually. No, this is wrong. Okay. So this is what was the proposal. Basically, take each line, convert them into pairs. So first line got converted into this. How are you? Second line got converted into this and this, while third line is just this one. Okay, you converted the line, each line into pair of words. Now, reducer will do the frequency analysis. Reducer will sort this data, bring it together, and then you can do the frequency analysis in reducer. Now, do you see any problem with this approach? Anyone? So, basically, the objective is to find out top 5 words which follow a particular word. Okay, so for this, you have to find out top 5 words for each word in your text. Top 5 words that follow after a particular word. And to do that, find out all the words which are following a particular word by creating a map reducer where key is the word and the value is the word that follows that particular word. Key is word value in next word. Mm, okay, let me understand your question. So take any word, make it a key, and the word that is following becomes the next word, and so on. Okay. So key is any word. Okay. So you can. I'm just putting tab instead of space. That will make it more clear. Okay. All right. So this is what it is. Now, do you see any problems with this approach, Arun? Ajay, Iraya, Deepak, Gunjan, Arun, Prashant, Savita, Tuhin. Words are repeated, right? In case the words are repeated, in case words are repeated, in those circumstances, they will be grouped together, okay? And hence, if they group together and in the frequency analysis, you increase their occurrence number, occurrence count, and they come in the top 5 one. The diagrams can overflow the memory. Yes. So in the reducer, if one particular word has got thousand of the words, then reducer will not be able to handle it. Yes. Yes. Very good point. Iraya, yes. So it's basically a memory constraint is there with respect to reducer. Excellent. So see, for each word there will be uh, lots of words, right? And and hence and hence in the reducer when all of those words get grouped together and fed to the reducer, the text might be too big for the reducer to handle. Okay, because reducer is a single node generally. Even if you distribute that, it might still be overflow reducer memory. We can have a limit of like keep word pairs only. Can you run multiple layer levels of reducer? Not really. The only thing we can do with reducers is split the set of keys to one machine and next set of keys to another machines and run different reducers on each of the set of the keys. Okay. So, but we can't do that. We can not say that we'll reduce the reducer's output. Okay. We cannot run the reducer itself on the reducer output. But multiple levels, if you mean that we can split the output of mappers to various reducer based on the key, then that is very much possible. But still, what here I am contemplating is, say for each word, there are a million words that are following it. Okay. Or let's say there are, say, uh, 100,000 words that are following a particular word. Still, your reducer will become the bottleneck. It may overflow the memory because it has to take all the values, sort them, find out the frequency of each word, and keep only the words which are of highest frequency. Okay, you got the problem, right? So basically, if there are so many words following how, and there's some 10,000 word or 100,000 word, reducer might overflow. This might overflow the reducer's memory, and so on. Okay. So this is one problem. Other problem you did not notice was U and Ram are coming in different lines, right? So we could not have we could not have something like U and followed by Ram here. Okay. Similar was the case with birthday and two. Okay. So those pairs went missing because we were operating line by line. Make sense? And third is that Ram followed by happy is completely wrong because sentence ended there. Okay. So if somebody is typing Ram, we should not be giving happy as the suggestion because sentence ended there. So which means that the next word which is coming up has no correlation with the previous one. Okay. It's not a part of the phrase. Right? How are you, Ram, is might be okay still, but it doesn't make any sense to give the recommendation, this kind of recommendation there, right? So how do you handle such scenarios? Okay, so there are multiple problems with it, this approach. Okay, these are minor problems, and first is last word of a line should pair with the first word of the next line if the sentence has not ended. The last word of a sentence should not be paired. And third is computation of frequency should be further map reduced because if a further if because this will overflow a memory. Okay, so somebody actually gave a great suggestion that I think Arun sent an email saying that you should form a key like this. Okay, you should form a key like this, and they put one here. Okay, and form key like this and then put one here. That's how you can solve the, and when it is ordered, then you know that this has got a frequency of 10, this has got a frequency of 5, and then later on what you can do is you can sum it up and only keep the ones which are in the top 5 highest frequency, and that's all. Okay. So that's how you resolve the third constraint here mentioned here, where computational frequency can be further map reduced by having key value, I mean both the words as the key and one as the value. All right. The first two we are going to discuss, these two we are going to discuss very quickly. Okay. All right. Savita, was I able to answer your question? Okay, okay. So basically, there were two approaches. One is one is you have say word one followed by word two. Okay, and word one followed by word three, and say word two followed by word three and word two and so on. Okay, so basically one approach is that you form your output of the mapper in this format. Key is first word and value is the second word. Now, uh, and reducer will do this thing. Okay, reducer will try to find out the unique minus C. I mean counts of all the uniques in a in that in the values in the values of. Okay, so I'll actually find counts of find counts of each values. Okay, find distinct counts. I'll say distinct counts. All right. So one is this approach. This approach suffers from the problem when this list goes bigger, your unique may not work. So instead of that, the other approach is to break down to form a key such as say put dollar here or put any other letter which does not exist in your word. Okay, and make that a single key. So I mean, the pair of words has been formed together in this form and put one here. And the moment another one comes up following that one, that also comes here. And at the end of the exercise, you will have sort of word one, dollar, word two. Earlier I used dash instead of dollar. Okay, and so on. Okay, so this pair will tell you that the frequency, the frequency of word 2 coming just after 1 is 2, and so on. Okay, in your reducer, all you did was sum it up, just like you in the word count example. And this would give you statistics of all the pairs in this text. And after you get the statistics, you can run another set of MapReduce to break it further and just figure out the top 5 out of the whole list. Okay, so that is another way to solve this problem. So was I able to explain, Savita? Okay, great. Okay, now let me move ahead. Okay, right. So the first two problem is something which we are going to discuss today in the second section. And right. So I have few questions for you. The data generated by mapper is given to reducer and then it is sorted or shuffled. Yes or no? So the data is generated by the mapper and given to the reducer, and after that it is sorted. So the whatever output of the mapper, it goes directly to the reducer as per the question. Do you think it is correct? Do you think it is correct? So first it is sorted and shuffled, then it is sent to the reducer. Great. Thank you, Deepak, and thank you, Savita. Yeah, probably you mean to say that, I mean, it is sorted first and then sent to the reducer. Okay, great. Okay. Mapper can only generate a single key value pair for an input value. Yes or no? So you are given a single key, a single value in the input, say a line. It, does it does a mapper necessarily have to create a single key value pair, or it can create multiple key value pairs? Great, 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 great. All right. By default, there is only one reducer in case of streaming job. Okay, streaming job meant this. I mean, so far we have only discussed the streaming job only. Okay, the one which we just demonstrated, even the before this discussion, before this discussion, and okay, so this is a streaming job, all right? So by default, there is only one reducer in this case. Deepak is saying yes. Great, great. So by default, there is a single reducer for the job. It can be split by specifying a command line option called mapred reduce tasks. Okay. And also we can define a combiner and a splitter. We can define a splitter using the MapReduce jobs also. I'll define MapReducer today for the case of Java. Okay. And in case of Java, the number of reducers are decided almost dynamically. So what is the role of a job tracker? Executing the MapReduce logic or delegating the MapReduce logic to task tracker? Oh, is it? Anyway, okay. So Savita's question before we move forward is when to use streaming versus Java. So the simple answer is whatever programming language you know well, you should be using that. Okay. So uh, if I have to do, I mean, if you know all the program, if you know Java, then do it in Java. Otherwise, you can use any other programming language of your choice. Okay. Okay. And in case, I mean, it is little slower in case of developing with Java. So what I do is I start my task with a simple streaming job quickly, and once everything starts getting into place and the logic starts expanding, then I move to Java. So Ajay's question is there a lag if we use there is a minor few milliseconds lag in case we use other languages because MapReduce is in Java, so virtual machine takes a less time to execute Java code as compared to do a system command execution. I mean, a system command when we say is in case of Java, we have to fork a process, external process out of the JVM and then execute that when it comes to the streaming jobs. Okay, so there might be few milliseconds or few maybe half a second at most lag uh, in case of execution, nothing more than that. So as long as we are using a language that is creating a binary, it is a streaming job. Not really, because we in any language, not here, this one. Basically, Hadoop started with the assumption that everybody will be using Java. But after some time, they realized that it is not possible at all. So they came up with a library in Hadoop. It's a Java library which can execute any command. Okay. So there's a difference between execution of a MapReduce job and a streaming job. And a streaming job is executed like Hadoop jar, and you ask Hadoop streaming library to execute. And there, uh, there in the mapper, you can specify any command, not only the binary, but your own Python program, Perl program, shell script, or anything. Okay, in the mapper. Here, right now, we are only showing you that there is this command, there is this command, right? Instead of that, you could also specify something like home my mapper dot python. Okay, in case you have a Python code. All right. Similarly, you can define your own reducer and you can keep that. So not necessarily binary, but any code. Just make sure that this code, if you go to the Unix shell and type this command, it should execute. Okay. It should be an executable in that sense. And other property of mapper reducer is they take the input from standard input and write to the standard output, just like Unix filters. Okay. So everybody is concurring that it is the B in this particular case. Okay. What is the role of job tracker? Delegate the map reduce logic to the task tracker. All right. So excellent question, Arun. Which user runs these scripts? To which user we need to give permission? Okay. So there is a user called HDFS and there is a user called Hadoop. And basically you should be giving a permission. Basically any executable you put it, your ideal way should be chmod 755. Everybody should be able to execute. Okay, and this folder should be accessible to everybody. Okay, in case you don't want to do that, then you should make sure that whatever, uh, I mean, it should be accessible to HDFS or Hadoop, whatever the name you by which the you installed while installing your Hadoop, you specify a username and a group name. In those cases, that is the one which is going to get used. Okay, and in our case, in our data center, probably it is Hadoop. Okay, that user. You have to make sure that everybody is added in the group called Hadoop, I think. I'll have to check that. So it is based on with what user Hadoop was installed. So which user runs this script? Okay. Now let's say I have HDFS for file system and MapR for job tracker, task tracker. Yes. Right. It is very much possible. Okay. It is very much possible. Okay. The only thing you can do is, I mean, in a complicated cases, like the way you see that when we are in the browser, in the Uzi or anywhere, there's a web view. Okay, and we are executing everything as a student. All right. So your case is very genuine. So in those cases, Hadoop or all of these services come up with a something called run as kind of argument. So you can tell that I want to run it as this particular user. Okay. In those cases, those kind of things can be handled. But as a practice, you make sure that put all of them into a same group and make the services accessible to each other. Okay. Okay. The map logic is executable preferably on the nodes that have the required data. Yes or no? Yes, it can have security issues. You are right, Aaron. So the way is that when you are executing or accessing HDFS, all right, you generally So HDFS will be allowing you to read and write only the files which you wrote, or you can give the permission like you have in HDFS also. You have ch mode and ch own, which means you can change the mode or the permission of each file in HDFS and change the owner or change the group. Okay. So you can keep, you can have basically the safest way to have a common group and give the permissions to only the group and keep on adding all of these users into that group if you're using multiple services for various things. Okay. So that is the safest way. Okay. Tranmeen has got a question. Can MapReduce execute some meshed Python and Java code? So in this case, that's an interesting question. So do you mean to say that I have a Python code in Mapper and in Reducer we have a Java code? Did you mean to say that? Or yeah, so yeah, you can do that actually. You can do that. In this case itself, in the say here you can, instead of saying this, you can actually say Java home and say my Java, my class path. Class, you define your XYZ jar. Okay. And then you have my.python. Okay. One is this way. Okay. One is this way. Other way is the other way to handle this. This is basically, this is not a proper Java MapReduce. Okay. This is just a plain simple any program, right? What you can do instead is that you can combine these input. Just a second. Okay. One is that you can do this sort of thing, right? This is in your Python, this is in your Java. Sorry, not my dot class. This, okay, my. If there is a class. Now, so one is this way. Other way to do this is have a basically uh, uh, a kind of Uzi job. Uzi, as in you create a workflow saying first finish this part and then do this. Okay. So that kind of thing. Have two set of map reduces in which first one runs as Python and second one runs. Yeah, it is actually, Savita, my screen is static. Is anybody else having problem with my screen? Oh, okay. 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 So probably my screen is having a problem. My network connection might be having a problem. And so I will have all the things. Just a second. So basically my network connectivity might be troubling because, okay. Okay. No. Let's see if it improves a little bit. Okay. So, okay. So I was able to answer trans means question. So can you, uh, okay. So what was your answers to these questions? So the map logic is executed preferably on the nodes that have the required data. Yes or no? Excellent, excellent. The whole of the chunk available on a node is fed to the mapper? Yes or no? The whole of the chunk available on a node is fed to the mapper. Okay, great, great. Okay, so answer is no. Okay, reason being, I will. Okay, so in case there are two separate data sets, they will be most likely stored in two different files and hence two different chunks. But the answer is no. Reason, I will explain to you this one very, very shortly, that the whole chunk does not represent the input. Why? Say, as we talked about, say for example, a streaming jobs. In the streaming job, in the streaming job, so what are the two separate data sets on, on the node, like in the democracy example? Okay. So was I able to answer your question? Because what I was saying is that in those cases, it will be two separate, no, two separate files and two different separate chunks. Okay. Because there were two different data sets and two different data sets, they were two different files and hence two different chunks. But here the question is, yeah. So I'll explain to you input split very shortly. Just make a note of this question and I will come back to this very, very quickly. So all I'm doing is I'm preparing the grounds for my input split. Okay. Basically, the whole chunk which is available on a node may not be a complete input for your mappers. Say for example, just now we discussed about lines, right? We take inputs in line by line. But since the chunk is a hard limit on the byte size, right? In case of HDFS, as soon as it reaches 64 MB, it will just slice it from there. There will not be a single byte more or less. Okay. Uh, Unless of course in the last chunk, which will be remaining of the one. But for the rest one, it will be very fixed size. It has nothing to do with the line number. So there are high chances that half of the line is in one chunk and half of line is in another chunk. Okay. And therefore the whole of the chunk cannot be fed to the mapper. So the input splits are created. Okay. Input splits, and then if there is a remaining portion left after input is split, it is transferred to the another node. Okay. Okay. So where does Hadoop store the results of reducer? Anyone? In HDFS or local file system? Perfect. Yes, Iraya? No, Deepak. Savita, it doesn't store in HDFS. So the question, I think my screen is not visible yet on Iraya's screen. So the question here is, where does Hadoop store the result of reducer? In HDFS or in the local file system? So as we discussed, oh sorry. The answer is HDFS actually. I read it wrong. I read it wrong. Okay. I read it completely wrong. So where does Hadoop store the result of a reducer? Now, everybody who answered as local file system would have got their answer right. I too read it wrong. So, and this is not the first time I have read it wrong. In my previous class also, I've read it wrong only. Okay. Okay. So yes, all of you are right, uh, except for those who understood the question wrong, including myself. So yes, in HDFS, the results of reducers are kept in the HDFS. Yes, yes. Tell me, Arun. Okay, okay. Yeah, that's a very good point actually. That's a very good point. That is why I generally repeat your questions. Okay. Thank you, Arun. Thank you. Yeah, that's a very good point. So let me try to see how can I capture this. How can I basically, okay. All right. I'll try to repeat your questions anyway. And because this takes up the space on the screen, that is why I generally avoid it. Okay. So, okay. Now, next question. Where does Hadoop store the intermediate data, such as output of the map task, in HDFS or file system? Quick, quick, quick. Perfect, perfect. So basically, perfect, Tuhin. Perfect. So basically, the way Tuhin has said, so in case of a mapper, what actually goes inside is that whatever output of the mapper comes out, it is put onto a circular buffer, which is slowly moved onto the disk in a parallel format. Okay, so it will be initially on the buffer and then moves to the local system. Yeah, you're right, Tuhin. All right, great, great. I've got a great set of team here. Okay, I've got a great set of candidates and in the file system. Perfect. So, okay. So MapReduce, now we are starting with MapReduce in Java. Even if you are not aware of Java, do not worry. It's not something very, very difficult. We can explain it. Okay. I can explain it and I'll make sure that you understand it. So first of all, I will be, demonstrating how to create a project in Eclipse. And then basically then we will all we will do is we'll how to deploy. I'll show you the step by step on how to deploy. Do not worry, it's not that big that difficult job. All right. So first step is you install Eclipse. Eh, okay, create a Java project. Okay, after that add all these libraries such as MapReduce, client core, Hadoop common, and all that into the project and change JDK to 7 to 6.0 if your server is having 6.0, and Preferably Java compiler settings also 1.6. Okay. And once you are done with that, then you move ahead and start writing the code. All right. So Savita's question is, for someone who doesn't know Java, do I need to learn Java eventually to be effective with Hadoop? My suggestion is yes, but not mandatory, and you don't require need to be very fluent with class and object oriented programming. Okay, but it will be very fruitful to learn Java, because what I noticed when I reviewed all big data platform as of today, most of them most of them their advanced programming need to be done in Java. So do we need to do these activities in our local machine? Yes. Yes. Okay. So basically, once you have installed Eclipse, you will have something on these lines. Okay. And uh, Tuhin Tuhin's point is that I should share the Maven settings for the jars. Actually, I haven't created a Maven setting yet, but I can create Maven settings. What I have done is I have created a project. Okay, I have created a zip file containing all the jars together, which you can download and add to your Eclipse project. Okay, that will be good enough for you. And in this case, as you can see, I have already set a Java compiler here to 1.6. Okay, here 1.6. Similarly, I have added all my libraries. Okay, all the libraries which I required over here, and this is my mapper reducer code. Okay, so I'm good enough here. Okay, all I did was created a new project, new Java project, and under that I added all these libraries, and I also changed my JRE to 6 by, I mean, how to change the JRE is using the Java compiler. Okay, and there is a, okay, okay, and here you can remove the Java, say this, and add another Java. Okay, add library and then add another Java. All right. Okay, you can say 6 or 7. This is how you can change it. Okay, it's not very difficult thing to do. Even if it is 7, that should also do. Now this is something which I would like to explain to you. So you create a class called stub mapper. Okay, which extends a parent class called mapper. By virtue of extending a mapper class, you you get a function called map. Okay, this is where you write your code. Okay, so all you are saying that I'm creating a mapper who is of behavior like a base class called mapper. My stub class is stub mapper. This is my name. I can write my mapper or whatever. Okay, I'm so sorry. All right. Here, so you have got stub mapper. It extends a mapper, and then here is my logic. This is my core logic. Okay, this says that take the value, split it, and then for each of these words which has come out, this is basically you took a value, okay, from the input, you splitted it by tab or space. This is my regular expression which says split by tab and space. Okay, and it gives out an array of words. It gives out an array of words. Here I'm iterating over that array of words one by one, and then basically writing it to the out into the context. Context dot write, and this is my key. This is my key, and this is my value. And value is, to notice that value is 1, and we have to just wrap it up in a new object called new long writable. You create a new object called long writable and say that. Okay, so this was the way you write your code, and this was the skeleton. This is the overall skeleton. You define you define your class which extends the mapper, and here you are also putting 4 identifiers. Okay, it is nothing but what you are defining the data type of the input to the mapper and the output of the mapper. Okay, so the best way is that you define an object. There are 4 values you are defining, which means you are concretizing your input and output. In general cases, because Java is a lot of type safe language, which means the data type is has to be fixed. Unlike our streaming job, where input and output both were considered as string. Okay, and we did a casting, I mean, to string and from string. That is little inefficient. Instead, if there are transfer between communication between mapper and reducer in terms of binary or in terms of objects, then it will be far more efficient. And therefore, a mapper is a bit efficient than your streaming job, but not too much. Okay. So here, so mapper says that these are the 4 data types I'm defining. My input should give you, the input key should be object, while the input value should be a text, and output key should be text, and output value should be long. It is saying that my stub mapper converts an input in the form of object followed by a text into text followed by a number. All right, object followed by a string and a string followed by a number. This is the input output relation. All right, now when you're defining map, again the same data type you'll have to keep it here, right? Whatever the key is there, these 2 data types will be here, exactly same one, like object, object, text, text. Okay, now and the output data type you are defining here, the same output data type have to be given to the context. When you're writing to the output, the same data type should be there, like text and long writable. Text and long writable. Alright. So this is what a mapper. Basically, other than specifying the value, it is saying that this is the data type I'm expecting, and this is the data type. These are the data types of the values I will be putting into my output. So this makes it very, very convenient for the for my mapper and reducer to communicate, instead of just keep on parsing strings back and forth. Okay, so I hope I am able to explain this in structure. Basically, here first I defined a class. Okay, so instead of using long from Java straight away, okay, they started using a new class called long writable. Now your question is, why long writable? This example, this example is basically the word count problem which we discussed. It is basically a word count problem in which we will be taking input lines and uh, putting as a result of mapper we are going to put the word as the key and the value as 1. Okay, so word 1, 1, second word, then again 1, and so on. So we'll put 1 1 1 1 in front of each word, and we'll make the word as the key. Okay, and in the reducer, all the words will be summed up together, aggregated together. All the values with respect to a word will aggregate it together, and our reducer will sum up those things. Okay. So long writable, they had to invent their new class instead of using the Java standard primitive type called long, because of little bit differences with respect to the syntax. Okay, he realized that having its own data type, their own data type, will make it easier for conversion into uh, communication in Hadoop. That is why I mean, the author of Hadoop created new set of data types. So context is the standard. Context is the output one. Whatever you put in the context will be taken by Hadoop and will be on which sorting and shuffling will run, and will be given as input to the reducer. The way in our program, in case of a streaming job, we were putting everything onto standard output. Here we are putting onto the context. Context is the object passed to the mapper by the framework. Okay, so you do this way. All right. So Arun, was I able to explain, answer you? So whenever Hadoop is going to run your code, it's going to pick up your class. Okay, and first it will create an instance of your class, and then for each of the input value, it is going to call your mapper again and again. All right, this map function again and again, and whatever you keep on putting into context, it will gather it together and then sort it later and feed it to the reducer. Okay, alternatively you pass you pass the count. I mean, Savita's question is that alternatively you pass the count of the word from mapper to the reducer. Okay, so passing the count is not that easy a task from mapper to reducer. The only thing you are given is this context in which you have to write. Okay, and and since the only way it communicates is you using the context, your map reducer does not communicate directly. Okay, therefore you will have to use one of the data types which context supports, and context supports the long writable. Okay, alternatively you pass the context. Okay, is long writable more efficient in this case? Yes. So long writable, other than our own choice, Hadoop came up with its own syntax. Okay. Okay. So basically, there are. I mean, if you, the other alternative would be like int writable. Okay. Other alternative will be like int writable. Okay. But here we are using long writable because we might we might require a bigger number to store the summation. Okay, we might require a bigger number to store the summation. That is why I'm keeping the long writable here, because we are going to sum up this number and then put it back. All right, although int can also be do a good job, pretty good job here. So this is our mapper code, and similarly this is our reducer code. I have skipped a lot of the other code. So remember that just now. So similar to mapper, we define a class called reducer. These are two separate execution unit, mapper and reducer. All right. And also note down that this object which is passed to your mapper as the first one is something which which Hadoop is giving to you. Okay, and is the byte offset in the line number in the file. It is not the line number because Hadoop doesn't know the line number, or because HDFS keeps in the byte sizes. So HDFS, when giving the input to the mapper, it gives in the byte offset. Okay, but you can deduce the line number from the byte size. Okay, so this is the byte size which is given as the input to you, byte offset basically, which from which byte your mapper input is starting. All right, now in case of reducer, it's the same format. What is my input data types and what are my output data type? The key and the value for the reducer, the key and the values, the type of the values which reducer will be producing. Similarly, key and the values which reducer will get, and key and the value which reducer will output. Okay. Oh. Okay. Okay. So reducer is still not there. Is it there now? Uh, I need to figure it out. Just a second, let me close everything. Uh, did my reducer screen came up now? Okay. So if I disconnect, can I join it back? Okay. Yeah. Let's just take a break for 10 minutes and then come back. Okay. Nothing to worry. Okay. In case something we are left with, we can cover it up. All right. Nothing to worry. This. Okay. So we are taking a 10 minutes break, which means that if I end up this GoToMeeting, there will be two videos, okay, uh, in the session recordings, okay, because every time you end up a meeting, you have a different set of different video. All right. Okay. So we are taking 10 minutes break. We'll come back at 8:30. Okay. Also, I will end the meeting. You will have to connect again. Okay.